Hey everybody, this is Larry. This is me doing virtual contest, weekly contest 483. 484. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this one. So now I'm finally up to live-ish. I mean, this is the last one, so yay, we did it. What else is there to say? I mean, that's it, whatever. Hit the like button, hit subscribe button, join me on Discord if I haven't already said it. I feel like sometimes... Just to be clear, I'm not like spamming saying that. I just forgot what I already said it. I am like having a stroke or something. Maybe this is the problem of old age. My advice: don't get old. All right. Am I ready? Yes. Let's go. Let's go. Let's go. 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 Do. Again, maybe I should reboot my computer first. What is my Firefox? Stuff is like loading so slowly. Okay, go. ABC is given a string, prefix XS, distinct. The number of distinct in the prefix is equal to length of the prefix mod 3. Okay, return the count, the residue. Okay. I don't know why this is still loading. What are you doing? What is this computer doing? Let me close some windows. No, I mean, not that much is loading. I think Leetcode is just being slow. I mean, definitely my computer, but... Alright, I mean... yeah. Oops. If length of if length of p is equal to I plus 113. I don't know why my computer is so slow. It's not using that much RAM, but it's too late. I should restart it. 212, right? Alright. If I get a wrong answer, I'm gonna blame it on Leetcode. Just because like my computer just like, I don't know, it's hard to test when it just doesn't seem responsive enough for you to test. But okay, Q2. Nums, the subarray nums is cosine if the sum of its elements is equal to at least one element within that same subarray. I guess if you have negative numbers as well. Return number of okay, 500 is interesting. I guess that just makes it n square, right? So then what are we doing? We want total. Right, so then if total is in something like that, right? I know I'm missing some stuff. So 5.2, right? Hopefully I didn't miss something silly. Okay, computer's too slow right now, or browser. I mean, I don't know. We're at a point where my internet browser is too slow. Oh well. Q3. Alright, count Caesar cipher pairs. S and T are similar if you have N words, M characters. Okay, fine. Choose S or T. Replace every letter in it to the next letter. Okay. Okay. Yeah, I mean that's straightforward, right? I mean this is yeah. Delta is equal to say root surface. Okay, so then now we subtract it from each character, right? C minus delta, and then let's mod that by 26, and then plus back A. Is that right? No, I mean, yeah. What's this? And then double check. Oh, I did not convert this back. Looks okay, right? Alright, and here we are at the hard. How are we doing? You should check how we're doing after, just to kind of see, well, how we're doing. Pretty soon we'll do it pretty fast, so we'll see. Alright, K and M. And most can choose any index I and increase num sub I by 1. Return an integer denoting the maximum possible bitwise n of any sub. What? Okay. Double check the constraints. Okay, so there's nothing crazy. Let me reread it. One operation, choose any I and then increase it by 1. Return an integer denote the maximum possible bitwise n of any subset of size m after performing up to k operations optimally. Okay, so m is equal to 2 means we have to get to choose 2, and again you can choose almost all of them. There are any bitwise things. K being 10 to 9 is interesting, maybe. Okay, and n is decent amount. So we want greedy, maybe. I mean, we do want greedy. That's the thing. What do we want exactly? Well, we want greedy, but how do we allocate the K? No, allocating K on the greedy is fine. Ish. Maybe? Do we always greedily? Yeah, maybe we do. Just one bit at a time. Sort by trying to think, but it's greedy. I'm just thinking through all the scenarios, right? So you never, in terms of preserving k, you never take a 0 to go to a 1, because that would just always be more expensive than having a 1 already. Can I binary search? Is it binary search? Just one bit at a time? I mean, it's like binary search. I mean, it is binary search, but it is just one bit at a time, right? And then we just keep sorting. There's only 32 sort of n, so I think that should be fine. Okay, yeah. Okay, yeah. I'll just continue, right? Let's keep consistent, say. Nums, but it shouldn't matter. So then now, how do I do the math on the prefix? So then it is the substring adding to this number, right? So then that means that the prefix how do I clean the number? So everything that's not on the bits that we care about, but the lower bits matter in the number of things that we need to do. Just that the high bits don't matter, right? So anything that's bigger than the biggest bit don't matter. I think if it's an else, then we just take away that bit from everybody to do the math correctly. Maybe. Yeah, maybe that sounds right. Something like that. Okay. Yeah, that's fine. Okay. Okay. So then now this should match the prefix. So if x is greater than target, then it just means that that means that we're good, maybe? I'm not quite sure about this one. Otherwise, then something like that. Well, maybe that's not quite right. Oh, it's the other way. Yeah, that's why. 422. I mean, alright, it's not right, but it's an idea. 4 is right. 4. Oh! I forgot we only need M of these. That's right. Okay. That's why I keep saying sorting and stuff, but I just forgot about the M part. Okay. So okay. Then we have. How do I write this? Needed. No, is it K? No, it's M. Yeah. Alright, 642. I don't know why I forgot about it. I structured it that way for that reason, but alright, looks okay. I'm not 100% confident about this. It's just a little bit more YOLO. And here we got it wrong, so that's okay. It's a quick one. Oh, Maybe I'm off by a little bit. It tries 16. 16 as an output doesn't make sense to me though. Does that mean just double whatever? So 8 trying 16. Oh, it tries 16. It removes the. Oh, I see. My logic is a little bit wrong, at least in the greedy part, because then now it tries 16, right? But then it flips off this bit. That's why, because it flips off the other bit. It flips on the 16 bit. Then now it doesn't want the second bit, so it flips it off. But because it flips it off, it goes from now 0 to 16. Which is not right, so this is wrong. How do I? This part was always the sketchy part to me, so maybe that was. Maybe I can just do this, but maybe I could just do something like this. I don't know. Because I was only hoping to do it on the prefix, so something like that maybe makes sense. I'm not super confident, but I'm gonna YOLO submit anyway. Oof. But that was the idea anyway, right? But this doesn't make sense though. Okay, so we try the 4, which is fine. 4. I mean, it has no overlap, but 4 is fine. I don't know about this part, the 0 part. I think that's probably why. K is equal to 3 means that we take the 2 and then we just made it to the 4. But the 5 doesn't really make sense. I don't know where we got the 5 from. We tried the 4, so 4 works, and then the greedy tries to do one more. Oh, because the 14 converts to 0 from this, and then the 0 we just add 1 is what it thinks, maybe. That doesn't even make sense actually, but Actually, it doesn't make sense. Hmm. So 8 doesn't work. 4, it works for sure. Because, yeah, it works. But then now just 0, 3. You know, there should not be a 5. Why? How is... Where do you get the 0 from? Oh, because this number... Yeah, I think this part is wrong. On the max part. I was worried about that. Because you have... why is it... Oh. How do I do that math? So if it's bigger, you still need the thing. Okay, so if it's bigger, you still need ones in the same place. It's not just that it is... Oh. How do I do that math? Okay. So I think the idea is still... Maybe I believe in it, but how do I do this math? Okay, so target X, but then what if you have the other way around? Huh. How do you do that math? Me not knowing, I think that's why I thought I could just reduce that to 0 for some reason, but that's not right. I don't know why I thought that, but that is... Do I do a DP? Do I need a DP? Because I'm thinking of something like if I have this number and then I just need well, even if I just need this number, I need to just increment by 1 so that it is a superset of this. That's fine, but how do I get this number to be 1? Oh, how do I not even this? Yes, you can take the fact that this is a 1 bit. How many bits until this is a superset of this? So that is going to be just an OR. Would an OR make sense? No, not necessarily, because in a different case, maybe we have someone like this, and then the OR doesn't make sense because Okay, so we have to do an if statement. So here to do. Okay, so then we need these 2 bits. This one we don't need. But it also kind of reinforces this if I have like okay, if I have something like this. Well, this number is then smaller, and then you have this. You just do this math, but we have someone like this. You still have to do this math on this suffix, right? I guess we can just do the brute force bit by bit. This is harder than I would have expected. I thought I had most of it, but maybe I'm wrong. Yeah, it was here, then now you need to just convert this into this, which is fine. It's not a... Does this one do anything? Why do I structure it this way? Is there another case I'm thinking of? I should have drew it out. Oh, how? I had something like this. Then this one doesn't even... How do I do the math? How do I do the math? Huh. that can be true. Just for... Maybe. YOLO. Not confident at all. Okay. I was worried a lot about this being wrong, to be honest, because I did see this quickly, but I thought maybe there'd be some edge cases, and I already got wrong answers. So, I mean, I had a good Q1 to Q3, but definitely 2 wrong answers on Q4 is not great. I don't know. I mean, some of it is, I just didn't think it through, obviously. I mean, it was just kind of, what was my submissions? Yeah, this one I kind of hacked in this part, maybe I should have thought about it. Though I don't know that I need this anymore. Let's see, do I still need this? Because of this fix. Because we just don't use those things anymore, so maybe we can simplify. Because that was in a way, I guess, a hack for this stuff of doing the math. But and that cost me 2 wrong answers as a result, because I just didn't really think about understanding it. I mean, but that's I don't know. I mean, 2 wrong answers obviously sucks, or not great in either case, but I don't know that I can do it without it. I think this is one of those tricky things where, I don't know. I mean, I did end up spending like 5 minutes just thinking on whether this is true or not. So it would have cost more in the beginning if I had really analyzed it. Yeah, I don't know. But yeah, this is kind of binary search, but you can look at it as binary search. It's very greedy. You can also use a heap here as well, like an M heap, to make it slightly faster, but I don't. But sort, this actual sort is very fast in Python, so that's why I don't really worry about it. And some of a subarray slice is also very fast. Actually, I'm curious about the timing. 1.7 seconds. I actually thought the reason why I didn't want to write this loop, to be honest, was that I thought it would make it much slower. I mean, and maybe it is still much slower, but I thought it would maybe make a timeout. Maybe something is to be said about premature optimization, but it was something that I was very worried about. Was then this makes it like b squared times n, which I don't know. Maybe. I mean, I don't know. With me, I do not trust Leetcode, so it is. Yeah. But I like the Q4, so I don't know. I'm just thinking through it. Yeah, let's do a quick retro. I don't remember the other ones. I mean, I think I could have been faster. It's just my computer was loading slowly. This is not a 2-minute problem. This one was actually faster. I did in 1 minute. I mean, this is just an n-square solution. I don't know. And this one, yeah, I also in 3 minutes feels a little bit slow, but actually, I didn't even need to convert it back to a string, but I guess it's just easy to print for debugging in case I need to debug. Alright, I mean, not gonna complain too much. I think this is an okay result for this contest, this problems, and the problems are interesting. But yeah. Alright, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.